But we can see the results over here to the left. They are really nice. We can see me in the foreground here, a lot of white pixels. Hey guys, welcome to the new video on this computer vision tutorial. In this video here, we're going to do depth maps with a monocular camera by using deep learning in Python. So in the last video, we did it in C++, but if you prefer to use Python and you want to know like how we can do it in Python instead of C++ and you're using that in your own project, then we're going to cover it in this video here, how we can load in a model that we actually like trained to do these monocular camera depth maps. And then we're going to like pass in the image through the actual neural network that we're going to use, and then how we can get the output in Python and display it again with OpenCV. But first of all, we're going to join the Discord server. I'll link to it down in the description here, and you can come join the channel, chat us about computer vision, artificial intelligence, deep learning, and so on. You can also become a member of the channel if you want to support the channel with a small monthly fee, and everything will go to create more and better quality content here on the channel. So thank you guys. So first of all here, we're going to have this short recap as we had in the C++ depth map video, where first of all, we're just talking about like the things that we've been through regarding like how we can actually like get depth information in the images by using stereo vision, and how to actually like estimate the distance and depth to different kind of points in the image, and also how to create these disparities and depth maps that we can now create with deep learning models instead, where we just pass in our image through the model. We can actually like use a monocular camera that has been trained to do depth estimation or like depth maps on monocular or like single images, and then we can use that later on to do actually like really nice projects without having a stereo vision setup or like some other different kind of 3D sensors for stereo vision, as I wrote here in the start. So how can we actually like estimate the distance using stereo vision? Like first of all, we need to calibrate our camera. We need to create an epipolar scheme using epipolar geometry. Then we need to build a disparity map and then convert that disparity map to a depth map. So we need to know a lot of different kind of things, and we need to combine all these things here together in stereo vision to actually like be able to generate this depth map, and then we can get these disparities and depth maps. So we have the information for each of the pixels in our image about like the depth to that pixel in, or like that pixel in the real world. But now we will do it with deep learning, and we're only going to use one camera or like one image that we're going to pass through this model here, and then we'll get the depth map, which is corresponding to the depth map that we'll get by combining all these things here that we've been through in the computer vision tutorial. So now we just need to pass it through a model, we get the result. So that's it. So let's jump straight into the Visual Studio Code here, and I'm going to show you how we can import the different kind of things. I'm going to show the models that we have, how we can set up these models, and then how we can actually like create our input from the images that we get in from our webcam, and then how we can actually set it up, set that as an input to our model, and then how we can do a forward pass of our image through our model, and then the output, and how we can actually like talk about the different kind of like outputs that we will get, and then we will show it in the depth maps here at the end of the video. But first of all here, I have a folder here where I just have my models, where I have the monocular depth Python script here. Everything is going to be on my GitHub, so I'll link to it down in the description as well. You can just go into my GitHub, copy the different kind of, and download the different kind of models here, copy the code. You can just run the Python script, and you will get depth maps from your own camera that you're connected to your computer. So here we have a folder with our models. So we're going to have two different kind of models. We're going to have the METAS version 2.1 large model, and we're also going to have the METAS version 2.1 small model. So it depends on if you're running on a CPU or a GPU, you might, and also the accuracy that you want. So it depends on, it's kind of a trade-off depending on your project, if you want speed or accuracy, and also depending on the hardware that you're running on. So we're going to test both of the models here. I'm going to show you like how we can set them up. We're going to test them on the CPU, and then we can like talk about like how we can actually increase the speed by using the GPU, as we did in the C++ video. So here we're just going to have these two models inside of the folder. We're going to specify the path here to the model. So we just have like the path here to the models that we have. So we have the models, and then we have these two different kind of networks that I just talked about. We have the METAS small and the large model. So we're just going to specify the name here of the model, so we can then use it later on. First of all, I'm just going to comment this small model out here. So we're going to read in the large model first of all, then we're going to process that, run the code, see how it works, and then we can try out with the small model and compare both of them. So to actually like be able to load in the neural network here with OpenCV, we're going to use the DNN module, as I have videos about here on the channel as well. I even have a tutorial about the deep neural network module that OpenCV provides, so we can actually like use that. I'm talking about in those videos like how we can read in the nets, different kind of types of nets, how we can set it up and so on, which we're going to use in this video. But here to actually like load the net here, or like the DNN module, or like the model here, we're just going to set our model equal to cv2.dnn module, and then we're going to use this method here, readnet. Then we're just going to specify the path to the actual like weight files and the architecture of our model. We're going to use the extension ONNX. So it both stores the architecture for inference and also the weights of that model. So here we're just going to specify the path, and now we have actually like loaded in our model into this variable. Then first of all, we're just going to check if that model is empty, because if it's empty, we could not load in the neural network. And you should definitely go first of all, check out the path, because that is often the mistake when we're trying to load in either images or neural networks. It is actually like the path that just messes up different kind of errors. So make sure to check the path if you get this error here, or if you cannot load the neural network. Then down here, we can actually like set the backend here or the target to CUDA to actually like use the GPU. So we can set our model here to set the preferable backend and also the preferable target to CV2, and then we go inside the DNN module again. Then we set it the CUDA backend, like the backend here for DNN module to CUDA, and we're going to set the same with the target as well. So if you have compiled and you have set up and installed OpenCV with CUDA GPU support, I also have videos about that on the channel here, how we can actually like compile GPU or like CUDA into OpenCV from like the binaries with CMake. So maybe go check those videos out if you want more like accuracy, or like you need a faster neural network running here, because it will actually like be really slow if we're running the large model here on the CPU, for example. So if you want high accuracy and a fast neural network, or like a fast application running as well, you will definitely need to use GPU over CPU. So here we're just going to set the preferable backend here as well. We're going to set it to use the GPU. Then we're going to open up a webcam capture here. So as we've done in all the other videos, like these are just standard stuff. And then I'm going to write the code down under here, which is actually like specific for this or like for this neural network here that we've loaded in. So here we have a capture of our video capture. So this is a webcam. Then we're just going into this while loop running as long as our webcam is open. Then we're just inside of this while loop. And then on the bottom, we just have like, if we hit Q at any time, it will break out the while loop here, release our webcam, and it will store all the windows that we have opened up with OpenCV. We also have some timers here, as we can see. First of all, we're going to read in the image, so cap.read. Then our image will be stored in this variable here, which is called im. Then we just get the image height, the image width, and also the channels by just taking the shape of our image. Then we're going to start a timer, end the timer here, and then we're just going to calculate the number of frames per second that we get by running this neural network here, or like doing this forward pass of our image from a webcam, like how long it takes. So actually, so we can actually have an idea of like how fast is our depth map actually created, and how fast is this algorithm or program running. So then we're just going to do that. We're going to put out the number of frames that we get. We're going to show the original image, and then we're also going to show the depth map here, which will be the output of our neural network that we're going to write the code up for here. So first of all, here we need to create a blob from our input image before we can actually like do a forward pass of that image through our neural network, because the input is actually like a blob. So here we can see I've just written some comments here. So we have for a large model, we need to, first of all, we need to scale all our values by 255. So we're actually like normalizing all our pixel values. Then we need to set a specific size here. So this is the image dimensions that we need to reduce our image to. So we have this square image here, 384 by 384. And then we're going to have some values here for the mean subtraction that we're going to do. So this is the pre-processing of our image before we can actually like pass it through our neural network. And we can also see here at the end that our channel orders is RGB. So to actually be able to create this blob here for the large model, we're going to set this variable here blob. Then we're going to have this CV2. So we're going inside and use the OpenCV module. Then we go inside DNN, and then inside of DNN we actually have something called blob from image. So this will create a blob from the image with these different kind of parameters. Then we need to specify the image that we actually like want to create the blob from. Then we need to resize the image or like scale our image, as we can see here. So we're going to divide that by 1 divided by 255, and then a dot here. So we actually like have floating point values. Then we're going to set the size of our image. So we have 384 times 384. And then we're going to have this mean subtraction here, which is actually like also just the values that we're going to set. So we have a comma here, and then we're going to set this mean subtractor. I'm just going to scroll over here so I can see the values. Oops. So first of all, here we have 123 here, comma, or like 0.75, 116.28, and then the last value here is 103.53 here. So now we have all the values here for our mean subtractor. Then we're going to set the last parameters here, which is just default, as you can go in and read in the documentation for this image to, or like blob from image. Then we're going to set a value here equal to true, and then the last one here, we're going to set it equal to false. So now we've actually created our blob here from our image. We can see the different kind of values here that we need to set, because we actually need to do all of these different kind of things before we pass it through our neural network. So now we have created our blob here, then we can go down and actually set the input to our model. When we're going to test this small model, we're going to do the exact same thing down here, but I'll wait with that. So here we're going to set the input to the model. So we just have model.setInput. And then we're just going to pass the blob here that we just created from the image up here. So now we have actually both created a blob, and we also have set the input equal to the blob. So now we can go down here and actually make a forward pass in our model or in our neural network. And to do that, we're just going to have this output, which we set equal to the model. And then we just call this forward. So we do a forward pass in our model. So now we just do a forward pass, and then the output of our neural network will be stored in this output variable. So now we've actually created and we got the output from our variable here. We actually need to, first of all, we need to resize our image back again, because we resized it up here, so we have this square image. So now we're going to resize it back again, and then after that we're going to actually normalize our image. So we're going to take the output, we set that equal to the output, and then we're going to take the values. So this is just how the output here is actually organized when we get it back from our neural network. You can go into the OpenCV documentation to actually see what this model here returns. So we need to take the 0th element here, because we need to take the output values. And then we're just going to take all the other different kind of elements that we have in our output, as we're going to do with this slicing. So now we need to resize the output, so we can actually display it later on together with the original image. So we're going to use cv2.resize, and then inside our resize we need to pass in our input image, and then we need to specify the size that we actually want to convert our image back to, and we already have the image width and the image height from the top of the program here. So again, you can just go down, you can just go into my GitHub, copy paste all of the code and just run it on your own computer, and you'll get the original image and also the depth map, so we can actually get the information, use that information in your own project and so on. So now we have these things. So the last thing we need to do before we can actually imp show our depth map is to normalize the output, so we get values between 0 and 1, and then we can scale those values depending on the actual depth that we want to obtain in our image. So here we're going to set our output equal to cv2, and then we're going to use the normalize function. So here we're going to set the input, or the source image that we're going to actually normalize. And then we're going to set a parameter here, which is none. And then we need to specify 0, and then we need to specify 1, because these are the values that we want to actually normalize our image to. Then we're going to have a norm type here. So we're going to set our norm type equal to cv2. And then we use this norm underscore min max. So we take the minimum and the maximum values, scale those to 0 and 1. So now we have the normalized type, and then we need to set the type here of our actual output. So we set the d type here equal to cv2 dot cv underscore 32f. So we have a 32-bit floating point value here as our output, or as the data type for our output. So now we have everything here. We have our output here, normalized values between 0 and 1, depending on the depth of these different kind of pixels that we have detected in the image. So now we have to have everything here. We're ending the timer, so we can actually get the number of frames per second that we get. And then at the end, we're just going to imp show the original image and also the depth map that we created by passing our image through our neural network. So now we can just go over the top here, run the program, and see the actual result. So first of all, here we're just going to open it up. It will open up the different kind of modules that we will need. And then we can go down here and actually see the original image, and then we will also get the corresponding depth map here. So here we can see we only get 1 FPS, so we get 1 frame per second. This is really slow because we're running this on the CPU. Because on this computer I haven't compiled OpenCV with GPU support, but I have videos about that if you want to use the GPU to actually like speed up this process, and then you can actually get up to like 10, 20, maybe 30 frames per second if you have a really good GPU. But we can see the results over here to the left. They are really nice. We can see me in the foreground here, a lot of white pixels. So the brighter the pixels are, the closer those pixels are to the camera, and the further away, like the darker the pixels are. So we can see the background here, it is like fully dark here, and then we can even see the TV here behind me is like some kind of like gray color. And then we get a brighter gray here with my face. We can even see my hand here in front of me. It is brighter because you can actually like see that this hand is in front of me, in the front of me. So it's actually like really nice. We get really high accuracy even when we're moving around. The only downside here is that we only get 1 frame per second if we're running it on the CPU, the large model here. We're going to see some improvements when we're going to run the small model, and also if you're going to run it on the GPU, as we saw in the C++ video. So if you want to see it on the GPU, go check it out in the C++ video. We get up to 12, 13 frames per second, and we actually have the same accuracy here with our depth map. But if you're not running a real-time application and you just want like a depth map, or you just have a single image that you want to create a depth map from, you can also just use this, and it doesn't really matter with only having 1 frame per second. So this is really nice, really nice accuracy that we get by just having a monocular camera. So to actually like run the small model here, we're just going to comment this model name up here out. So now we're going to run the small model, and then we need to create a new blob from our image, where we're actually like reducing the size of our image. So instead of we have this 384 by 384 image dimensions, we're going to reduce that to 256 times 256 here in this example. But I'm just going to copy paste this code up here because this is exactly the same. We can also see the mean subtraction. It will be the same here as well, because these are just the pre-processing techniques that we're using before we're actually like passing it through our neural network. So the only thing we need to change here is actually like the image dimensions. So we're going to set it here to equal to 256 and 256 here. So now we've created this new blob here. We've commented out the small model up here. We don't have to do anything else. We just need to do these 2 steps, and then we can run our program here again and see the results for the small model, where we will get a faster algorithm running, but we will also get more uncertainties, and we will not get that accurate depth map. We can see here that we get around like 11, 12, sometimes it peaks down to 8 frames per second. So this is a faster model. We can even use this in some kind of real-time applications, even just running on a standard CPU. We can see we still get some information about like my hands is like closer to the camera than myself, and also the background, it is further away, it is darker, but we can see we don't get the same accuracy as in the large model. We can see like even the background is still pretty bright here compared to the large model. We get like more uncertainties here when I'm moving around in the frame, but we get a faster model if we're going to run it on a better device, or we don't need that high accuracy, or like that high accuracy in our depth map for our application. So again, it depends on your application and how accurate you want your depth, and also the different kind of things. It really depends on the applications. And also if you're running in real-time applications, again, you will definitely need a GPU. Run the large model on GPU and you'll be fine. You will get up to 20, 30 frames per second. And it is more than enough. You don't need to talk about like stereo vision anymore. You can just use this model, pass your image through the model, get the output, and then just work with the depth map that you get. Create your application around that depth map, and it's just really easy to set up. Go take the Python script, run it, and you get the depth map. So thank you guys for watching this video here. We've been through like how we can actually like get this depth map from a monocular camera. So it's actually like really nice that we can now use deep learning with a monocular camera. We don't need a stereo camera. We can just use a monocular camera, get depth information, use that in our project. So thank you guys for watching this video here, and remember to hit the subscribe button and bell notification under the video. And also like this video here if you like the content and you want more in the future, because it just really helps me and the YouTube channel out in a massive way. I'm currently doing this computer vision tutorial here where we like over time we add different kind of stuff like camera calibration, stereo vision, now depth estimation with only a monocular camera. We're talking a lot about different kind of things within computer vision, and now we're starting to combine it with deep learning, which I also have a tutorial about. So I'll link to one of the tutorials up here, or else I'm gonna see you in the next video, guys. Bye for now.